وصلت هلا بالميوزيكال.
Okay.
الميوزيكال.
So the idea was to try to relate
هلا
R
I'm gonna
and
finish
theta
up.
in a geometrical way. How to do this? Let us look at the figures they gave us and try to do an analysis about how we can relate R and theta. Okay. So first, they told us that the spotlight is located at 100 meters from the searchlight. Okay. So, sorry, the wall is located as 100 meters from the searchlight. So we can say that this is the distance between the searchlight and the wall. And whenever we talk about a distance, this means that this line is perpendicular to the wall. So this angle with the wall is equal to 90 degrees. And you know from math that if I have a line perpendicular to a plane, this means that this line will be perpendicular to any line within the plane. How can I benefit from this information? Because what is R for me? R is the distance between the searchlight and the spot on the wall. Okay? So this is R for me. And then this point of R, the extremity of R vector, is on the wall. And this point, which is the projection of the searchlight on the wall, is known. It's at a distance of 100 meters from the wall. So if I join these 2 points, I can be sure that this angle is 90 degrees. Why? Because this is the distance to the wall, and then it's perpendicular to any line on my wall. So if I want now to put it on a side, I have a triangle. This is 100 meters. This line on the wall is doing with this distance an angle of 90 degrees. And the position vector R is here. This is my position vector R. Okay. And it's doing with this line an angle, a variable angle theta. Okay, but here it's a 2D motion, and theta is varying in this plane. Okay, I'm varying theta in this plane. So it's the motion of my light is, if you want, the position vector moves in 2D. Okay, and then my spot will move on the wall. So now I can easily relate from this figure R and theta, because R constitutes the hypotenuse of a right triangle. So I can write that since 100 meters is the angle adjacent to theta, I can write that R times cosine of theta is equal to 100. So this allowed me, this geometrical relation allowed me to relate my R and theta. Okay, and when I have this relation, I can proceed in cylindrical coordinates. And please remember, as I told you before, always derive the easiest form. Yani instead of writing now R equal 100 over cosine and deriving it, okay, which will be a little bit complex. Yani it will start first by a simple derivative, and after it will become much more complex. Always derive the simplest form. It will give you the same result in an easier way. Okay, what should I do, and what are the derivatives that I should do? I want to determine magnitudes of velocity and acceleration for a specific angle, for theta equals to 45 degrees. Okay, so to do this, first let me go back to what are the relations needed, what are the variables needed. You know that in cylindrical coordinates we have v function, v has two components, vr and v theta. So let us start, if you want, with v. V is r dot ur plus r theta dot u theta. So to be able to compute the velocity, I need to determine what is r dot, which is the derivative of r with respect to time, and what is r and theta dot. For theta dot, it's simple. They gave me in the given that the searchlight is rotating at constant rate of 4 radians per second. So theta dot is given, it's equal to a constant equal to 4 radians per second. Automatically, since it's a constant, you can directly deduce that theta dot dot will be 0, and you will use it for the acceleration. Okay. So we don't have a problem with r and theta dot. Theta dot is given. R we can calculate it based on our geometrical relation, which is r cosine theta equal 100. Specifically, I am interested at theta equal 45. So all I have to do is to replace here theta by 45 and then get r at 45 degrees. The challenge is only with this term, which is r dot. How can I appear the term r dot? What should I do? Who can tell me? What should I do? Exactly. I will derive the expression r cosine theta equal 100 with respect to what?
Theta.
No. Why not theta? Who will tell me? If I derive r cosine theta with respect to theta, will I obtain the expression of r dot? R dot is not the derivative of r with respect to time, with respect to theta. It's the derivative of r with respect to time. So if I derive this relation with respect to theta, I will not get r dot. I will get dr by d theta. Okay. If you want, you can do this. You can say, let me find first dr by d theta, but to find r dot after, what should I do? If you derive this relation with respect to theta, what is the next step to move to r dot, which is dr by dt? What should you do?
Chain rule.
Exactly, chain rule. So after you do dr by d theta, you should multiply by what?
d theta dt.
Exactly. Yes. You should multiply by d theta over dt, which is theta dot equal to 4. Okay, so you can do this method, derive first with respect to theta, then multiply by theta dot. But what I advise you to do is to derive directly with respect to time and the easy relation. The easy form is the following one: r cosine theta equal 100. Let us derive this expression with respect to time. Okay, so if you want to derive with respect to time, then we have the product of two functions, r and cosine theta. So we have first u times v, so we do u prime v plus v prime u. Derivative of r with respect to time is r dot. So r dot cosine theta plus now uv prime, so plus r times. Now we want to derive cosine theta with respect to time, but since cosine theta is a function of theta, then we use the chain rule. We say, let us derive first cosine theta with respect to theta, and then multiply by d theta by dt in order to have the derivative with respect to time. Okay, so here we use the chain rule in order to derive the second term with respect to time. This will give us equal to the derivative of 100, which is a constant, so it's 0. So we obtain the following result: r dot times cosine theta. Now the derivative of cosine theta with respect to theta is minus sine theta. So minus sine theta times d theta by dt is theta dot, so times theta dot, which is 4, equals to 0. So we deduce that r dot. Now we have the expression of r dot. R dot is tan of theta times theta dot. And since theta dot is a constant, you can directly replace theta dot by 4. Okay, so it's tan theta times theta dot. And in this way, you are able to find the expression of your r dot. Okay, and then now you can calculate at the instant you want. Here you are interested at theta 45, so you replace theta by 45 degrees. You get that r dot at 45 is tan 45 times 4, and now you replace into your velocity expression and you get your velocity vector. Okay, now the next step is to find the acceleration vector. To find the acceleration vector, we need to determine, if you go back to the expression, we need r dot, we need theta dot, we need r, and we need r dot dot and theta dot dot. We already calculated in the previous step to find the velocity. We calculated already r at 45, r dot at 45, and theta dot is given. We still need to have r dot dot and theta dot dot. We already mentioned that since theta dot is constant, this is 0. So we just now have to compute what is r dot dot. And again, I always advise you to derive the easiest form. So here you are able to find an expression of r dot. Let us derive this expression with respect to time to get r dot dot. Okay, let us do it in a general way. If theta dot was not constant, what should we do? And then after we will apply that theta dot is constant. So this is the expression of r dot. It's tan theta theta dot. So if I want to get r dot dot, I should derive this expression with respect to time. Okay, so I have the derivative of tan. So I should derive first tan theta with respect to theta. If you want, I advise you to derive this form, not this one. Because, for example, if you don't know what is the derivative of tan theta, okay, instead of doing it sine over cosine, which is u over v, and doing the derivative, which will be a little bit long, it will be easier to derive this form. So always you have always several approaches to get your derivative, but try to do the easiest one. And if you don't know what is derivative of tan theta with respect to theta, you can memorize it. If you know it, it's fine. If you don't know it and you want to find it, and you should write tan as sine over cosine and do u prime v minus uv prime over v square, etc. Instead of doing all of this, derive the form that is simpler, this one, before taking, if you want, cosine to the other side. So we'll do both here. So if you know what is derivative of tan theta with respect to theta, it's fine. Use this form, and then you multiply by theta dot and the plus tan theta dot dot. But since theta dot is constant, then theta dot dot is 0. So automatically this term will drop, will cancel out. So you just have to find this term. For me, what is easier is to derive the first form, because you can easily, the derivative of cosine and sine are very simple. Everyone knows that. So we can go back to this relation and say, we know that r dot times cosine theta minus r sine theta times theta dot equals to 0. Let us derive this relation. Okay. Also, since theta dot is constant, it will be easier to directly replace it. So replace it directly, so you don't have to derive it since it's a constant. Okay. Derivative is 0. Then if you derive this expression with respect to time, you get the following. Derivative of r dot is r dot dot, and this is v, so r dot dot cosine theta. Now, if we continue, plus r dot times the derivative of this term with respect to time. We use the chain rule. Derivative of cosine is minus sine, so we can put here minus r dot sine theta, and don't forget to multiply by theta dot to have the chain rule. Okay, and finally you have this term. For this term you have minus 4 times this is u times v, so minus 4 r dot sine theta, and the derivative of sine with respect to theta is cosine, and we multiply by theta dot, so minus 4r cosine theta times theta dot, which is 4. Okay, and then you can get what is r dot dot. So you have several possibilities. Use what you want. Okay, but Anna, in general, I derive the easiest form. Okay, now here in the solution of the example, they didn't derive the easiest form, and look, they got very they got complex relations. If you don't know derivatives of secant and etc., no need to go over this procedure. And from the beginning, don't take cosine theta to the other side to get secant of theta, and then you have to know what is the derivative of secant of theta to proceed. Okay, so always try to derive the easiest form to avoid complex calculations. And of course, at the end, you will get exactly the same result. Okay, and then after finding your vectors, you can calculate the magnitude. So for velocity, you do radical vr square plus v theta square. And for your acceleration, it's radical ar square plus a theta square. Okay, so this is for magnitudes. Now, let us do another problem. In this problem, due to the rotation of the forked rod, ball A is traveling across a slotted path, a portion of which is in the shape of a cardioid, which has a relation r equals 0.15 times 1 minus cosine theta, where theta is in radians. If the ball's velocity is 1.2 meters per second and its acceleration is 9 meters per second square at the instant theta equals to 180 degrees, determine the angular velocity and angular acceleration of the fork. Now let me check the chats before if you have any question. Hashim, it was fine for you, or do you want me to repeat anything? Because I didn't understand the question in the chat. Can you tell me what was your question? Okay, if you are hearing me, you can please answer to see if it was fine for you or not. Yes, 2 slides upwards. Yes. The one for velocity or the one for acceleration? Okay. Yes. What was the problem with the velocity? To get the velocity, you should get r dot, and theta dot. Okay. So here, to get r dot, you should derive the equation. Shouldn't we add an r in the end? I didn't. why you should add nr at the end? I didn't understand. Look, the expression of velocity is r dot ur plus r theta dot u theta. Okay? You should find what is the expression of r dot. And r and theta dot, you have them. Theta dot is 4. R is, you calculate it at 45 degrees. Okay? Now to get r dot, how you get it? You should derive the relation r cosine theta equal to 100. When you derive this relation, you will appear the term r dot. I'm not understanding what do you mean by adding r in the end. Oh, okay, fine. Right. So let us start another problem. Due to the rotation of the forked rod, ball A travels across the slotted path, as we said, and they gave us the equation of the path. This is the path equation. It's r function of theta. So here, since they gave us already the path as r function of theta, so this is an indication to use cylindrical coordinates. Okay, so where theta is in radians. Please pay attention that for your theta values, whenever you replace, you should use radiant for your equations. You can, if you want, here in your calculator, if your mode is degrees, it's fine. Then you put your angles in degrees. Yani here, when you use the value of theta in your calculator, make sure if the mode is degree or radian for cosine and sine. But for example, if r was 0.15 theta, okay, not without cosine, when they tell you theta is in radians, and when you want to calculate r, you should replace theta by its value in radiant. You cannot replace it by its value in degrees, because you'll obtain different results. Okay, here it doesn't matter in this expression if theta is in radiant or degrees, because you can fix the mode of your calculator as you like. Yani you can say, I want to work in degree mode with my calculator, so the angle you provide to your calculator is in degrees. But if you have theta without cosine and sine, and you want to replace it, pay attention to replace it in radiant, not in degrees. Okay, now we have our function of theta, and they are interested into finding the angular velocity and angular acceleration for the position where theta equal to 180 degrees, knowing that the magnitude of velocity and the magnitude of acceleration are given. So in this problem, we are doing it in the reversed way. Instead of giving us angular velocity and angular acceleration and asking to get the magnitude of velocity and acceleration, they did the opposite thing. They gave us the magnitudes of V and A, and they want us to get what are theta dot and theta dot dot. So the angular velocity is theta dot. We want to find it. So this is our first unknown. And the angular acceleration, theta dot dot, is our second unknown. Eli, if you want to find the radius of curvature, you mean you want to work in a NAT? The idea here is to find the radius of curvature will not be, if you want, centered at point O. It will not be centered at O. Okay, so at each position, if you want to work in UNUT, you need to get where is the position of the center of curvature, and you will not be able to find it easily. And you can convert this equation to x function of y and use the formula of rho. Okay, but the idea is that it's not straightforward to use UNUT. You should work with URU theta. No, to find, no, you cannot say that V is R theta dot. Please pay attention, please guys. V equal R theta dot is only used in circular motion. So you cannot say here that the angular velocity theta dot is V over R. It's wrong. Okay, because here your reference point is not the center of curvature for your path. Okay, so if you remember in the example of the circle I gave you, if you select the reference point at the center, then you can say that the linear velocity is R theta dot. But if you select any other point of reference, okay, then you will not get that V linear is equal to R theta dot, because then UR and U theta will be different than UN and UT. So please pay attention. Okay, Elia, it's very important to know that we cannot do this. So whenever you have a path of motion and you don't know exactly where is the radius of curvature, you cannot use R theta dot, since R, which is the position vector, is not representing now the radius of curvature. Okay, so this is why what the method to do is to write the expression of velocity and acceleration in cylindrical coordinates. So you start by saying, I know the velocity V equal 1.2, but how can I get what the magnitude in cylindrical coordinates? 1.2 is radical V radial square plus V tangential square. So let me find the expressions of VR and V theta and replace back into this equation to get my unknowns. Okay, so first we know that by definition VR is R dot, which is the derivative of R with respect to time. Okay, and since R is provided as a function of theta, so to calculate R dot, I should use the chain rule. So I say that this is equal to dr by d theta times d theta by dt times d theta by dt. Okay, let us derive first the expression with respect to theta. We have minus cosine theta, the derivative is sine theta. So it's 0.15 sine of theta times theta dot. Okay, times theta dot. Now, since we are interested at the position theta equal 180 degrees, sine of 180 is equal to what?
0.
0. So at this position, يعني بس هون guys, for only theta equal 180, this component will cancel out and V will just be equal to V theta. But if you take any other angle different than 180, you will have both VR and V theta. Okay, so here it was a particular case where V, for this position of 180 degrees, since VR cancels out, then this term will cancel and I can say that V is equal to V theta. But for any other angle, it's not the case. So please pay attention. If you have any other angle, you should go through this procedure. You get VR first, and then you express VR function of theta dot, and also you express V theta function of theta dot, and you replace in your formula. But since at this position, particular position, sine theta is 0, VR will cancel out and V will be equal to V theta. So we are dealing with a particular case, and we know that V theta is R theta dot. And at this position, what is R? At this position, to get R, we just replace in this formula cosine theta by 180. Okay, we know that cosine 180 is -1, so we have 1 minus 1 is 1 plus 1. So r at 180 degrees is equal to 0.3. Okay, so for this particular location at 180, I have v, which is 1.2, equal to 0.3 times theta dot. And since the only unknown is theta dot, I can calculate the value of theta dot. So theta dot, so the velocity equation will allow me to get theta dot equals to 1.2 over 0.3. Now, in case they gave us any other angle, so we have to express VR, then we replace here VR function of theta dot, and we have V theta function of theta dot. So we get then the magnitude of velocity function of theta dot, and we can get the value of theta dot at the corresponding location. Okay, any question on this part, how we got theta dot? Okay, now we'll do exactly the same procedure to get theta dot dot by expressing A magnitude. So A magnitude is equal to 9, is equal to radical of AR square plus A theta square. Okay, and let us start to find the expressions of AR and A theta. To start with AR is equal to R dot dot minus R theta dot square. We already have found together from the previous step at 180 degrees what is R and what is theta dot. We replace. We still have to compute R dot dot. Okay, to find R dot dot, we derive R dot. So we already have found together that R dot is equal to 0.15 times sine theta. Please never say that I got R dot equals 0 at 180. This means that R dot dot is also 0. We never derive a number. We derive before replacement. Okay, so you go back to your equation. R dot is 0.15 sine theta theta dot. To get R dot dot, we should derive this relation. So R dot dot is equal to, we use here, we have U times V. So, and we have 0.15 as the constant. So 0.15 times, we have the derivative of sine theta is cosine theta times theta dot. Okay, and don't forget, please, to multiply by theta dot again, because when you derive sine theta with respect to time, you do the chain rule. So you do a derivative of sine theta with respect to theta times d theta by dt, and don't forget your v. So you get theta dot square plus, now you do uv prime plus sine theta times theta dot dot. Okay, now since you are considering, you are interested in the angle 180 degrees, when you replace an R dot dot for 180, you have sine theta will cancel out, so this term will drop, and cosine 180 is -1. So you get that for this position at 180 degrees, so R dot dot at 180 degrees is equal to minus 0.15 times theta dot square. And you have already evaluated theta dot, so you can get your R dot dot at this position. You still need to compute A theta. Okay, so to get your A theta, you write the formula. What is the expression of A theta? A theta is equal to R dot dot, 2R dot theta dot plus R theta dot dot. Okay, now we have already computed together the value of r dot at 180. We have seen that at 180 r dot is 0, so this term will cancel out. Okay, and we just have that a theta is r theta dot dot. So we were able to express a theta function of r theta dot dot, and the only unknown in our equation will be theta dot dot. So now I replace back into 9 equal to radical. I replace AR by its value. I already calculated AR. I replace it plus a theta square, which is r square theta dot square. I know the value of r. Okay, r is at this position is 0.3. I replace it. I replace AR. The only unknown is theta dot dot. I can calculate it. And in this way, I was able to find the expressions of the angular velocity theta dot and the angular acceleration theta dot dot at theta equal 180 degrees. Okay, any question on this problem?
No, thank you, Doctor.
Clear.
Welcome, welcome, guys. Yeah, bye bye. Yes, okay, I will rewrite r dot dot. Yes, okay. To get r dot dot, you need to use the derivative of r dot. Okay, so this was r. When you derive the first time, what is r dot? R dot is, you have 0.15 is a constant. When you derive it, it will cancel out. Minus 0.15 cosine theta, so the derivative is 0.15 sine theta theta dot. Okay, you use the chain rule to get r dot. Now, to get r dot dot, you will derive this relation. So you derive this relation to get r dot dot. So you have the product of two functions, u times v. Okay, so to do this, all you have to do is 0.15, which is a constant, times, here you have u times v. So when you derive the first function, okay, you do the chain rule. Derivative of sine theta with respect to theta is cosine of theta. Don't forget that using the chain rule, you should multiply by d theta by dt. Okay, and what is your v function? Your v function is theta dot. So again, you multiply by theta dot. So since you have d theta by dt times theta dot, it's theta dot square. And you add to it plus u v prime. U is sine theta, and v prime is theta dot dot. Okay, so in this way, you obtain that r dot dot is 0.15 cosine theta theta dot square. So you remove this and put square because d theta by dt is theta dot plus sine theta theta dot dot. And now at 180 degrees, you replace. Okay, cosine of 180 is -1. And sine of 180 is 0, so this term will cancel out. So you get that for 180 degrees, what is r dot dot? It's minus 0.15 theta dot square. And we already got theta dot from the previous step, so you can get the value of r dot dot. Okay, Hashim? Any other question?